Take note again here that as n, the input size, gets arbitrarily large, we only worry about terms that will grow the fastest as n gets large. To this point, big O analysis is also known as asymptotic analysis. So say for example, if we have T of n equal to 4n plus 5, which of these two terms do you think will mostly affect the value of T of n as n gets larger? As n grows large, take note that of these two terms, 4n and 5, which of the two will grow fastest as n gets very large? Of course, 5 is constant, while this term is dependent on the value of n. When n grows, 4n grows also. Okay, so when n grows, the term 4n also grows, while 5 is fixed. Okay, as this grows very large, this is not growing at all. Okay, that is why when we compute for big O, we would say that big O is simply n. We even cancel this one out. Okay, and say for example, if our T of n is 2n cubed plus 3n squared plus 4n plus 16, if that is our T of n, which of these four terms, this one, first term, second term, third, and the fourth term, grows the fastest as n gets very large? This is constant, fixed. Okay, this grows but not as much as this one, right? So this grows larger compared to this one, but of course this term grows the largest compared to this term. This term grows the largest compared to this one. Okay, so among the four terms, 2n cubed, 3n squared, 4n, and 16, this one, the term with the highest power, is the one that grows the fastest as n grows. So it is 2n cubed that grows the fastest as n grows. That is why our big O for this T of n is simply n cubed. We can even cancel that one out. Now, some problems are famous enough that the algorithms have names, as well as some procedures being common enough that the algorithm associated with it also has a name. For big O1, we call it constant. For big O log of n, we call it logarithmic. For O of n, we call it linear. For O of n log n, we call it log linear. And for n square, we call it quadratic. For O of n cube, we call it cubic. And for O of 2 to the n, we call it exponential. And here's the meaning. If T of n is any constant value, then the big O is O of 1. If T of n is this, C log n plus any value, then the big O is O of log n. If Tn is C of n, then we call it O of n. And the name for that is linear. Okay, if T of n is any coefficient constant times n log n plus any value, then the big O is n log n. Okay, it is always the term that grows very large when the value of n grows large, and we simply drop the coefficient. So we drop the coefficient when we write the big O. And if T of n is Cn squared plus any other values following it, this one being the highest power, then the big O is O of n squared. If it is Cn cubed plus any other terms that follows, then big O is O of n cubed, and if T of n is equal to any coefficient times 2 to the n plus any expressions that follows, then the big O is O of 2 to the n. We have here a Python sample code for plotting the various functions or algorithms. So we are trying to plot here the constant, the logarithmic, the linear, the log linear, the quadratic, the cubic, and the exponential, and check which of these functions or algorithms has the worst or the least running time or order of growth. So let's try to run this in our Jupyter notebook. So we paste our code here and run. Okay, so we get this output. If we're going to rank the functions, constant, logarithmic, linear, log linear, quadratic, cubic, and exponential, based on the graphs, the curves, what is the order, which has the least running time, and which has the worst running time. From the graph, the least is this one, constant. Okay, this is the constant. And next would be the logarithmic. Next would be the linear. Next, the green is log linear. Next, the red is the quadratic. Next is the blue exponential. And the worst is the cubic. Okay? So this is the least up to the worst running time or order of growth in terms of the big O. Okay, so we have this graph which we did already a while ago in our Jupyter notebook. And the ranking is cubic is the worst. Okay, so from constant, the least runtime, to the worst runtime, that's cubic. And then we have here something also from the internet, from Wikipedia. Okay, and this is another one from the internet. So notice that we got the same, we got a consistent result